Okay, it should work, right? So everyone, hello. Okay, new topic today. Let's see, let the stream first start and then we can start with the next topic. It will be overloading and then comparison operator. What is a comparison operator? I think I get it. I think I get it what the comparison operator is. Let's see who's gonna arrive here. Sometimes if I'm watching Twitch, I'm wondering, you know, what I'm seeing there. I mean, the text is not that clear, right? From maybe I should change it. Give me a second. Give me a second. Where is it? Prisma chat. We need like. It has to be bigger, right? Like way bigger, like something like this, really big. And then I have to shrink it, or I have to shrink it before. Something like this. And then I can make it bigger. That's perfect, right? And then I can make it here bigger also. Well, what? This is not working? What the heck? Interesting. What? So I can increase the font, but that's it. I mean, then we're gonna do this. I think this is fine. Okay. Let's start with the new topic then. The new topic will be, well, I don't like it if the text is like kind of blurry or something, you know. Have to fix it quick. And here we have to higher the font size of 30, I think it was, right? Still blurry. Let's do 40. Yeah, 40 is too much. What was it here? 33. Yeah, I think this is okay, right? This is alright. I mean, I could do it like this and then I say, for example, 30. Oh, nice. If it's not working, I like it. Yeah, this is way better. I'm gonna do it this way. Okay. Hello, everyone. Let's start with the next topic, and the topic will be overloading the comparison operator. Oh yeah, I'm so excited about that. My microphone is working. Yeah, it is indeed. And we just need a browser. Here we go. Here we go. Okay. Overloading the comparison operators. In lesson 6.6, relation operators. Wait, the microphone have to be a little bit more like this. Relation operators and floating point comparison. We discussed the 6 comparison operators. Overloading this comparison operator is comparatively simple. Relation operator and floating point comparison. Did I did this topic? Yeah, overjumped it. Oh, I remember. Yeah, I remember. Okay. Because the comparison operator are all binary operators that does not modify their left operands, we will make our overload comparison operator friend functions. So that's why, you should use a friend function if you not modify the left side, right? Yeah, the left operand. Here's an example car class with an overload operator and operator not equal. So this car class, right? If you're probably studying engineering, most of the time, if you are learning C++, you're doing it. There will be at least one exercise that will be like car related. Then we have class car. Then we have private stud string make and stud string model, right? Then we have here our public. This is our constructor. And then we initialize the stuff, right? Can we say that we're gonna initialize it? Is it correct? So I think it is. We initialize make with make and so on, right? And then we have a friend bool operator. Here we have this overloading thing, right? For this is like a assignment operator, right? Comparing, right? We're doing it for the comparing and for the not equal. And then we say it's const car reference C1 const car. So everything is const, read only. Okay. And that's like a forward declaration, what we have here. And then we have bool operator. Of course, it's a bool. It's our return type. Right, this done. So, yippee yay. So now the bool operators. So we had like here the forward declaration. Here we have the declaration. Then we say C1 mmake is equal C2 mmake. And this is OR, right? C1 m model is equal C2 model. Okay. Wait a second, what are we returning here? So we're just returning true if this is true or what? Right. This is the case, right? Correct? I never did it like this way. This is interesting. I was not aware of that you can do it like this. Let's take this quick. How is what is the name of it? Yeah. Okay, let's do it. So like this, here we go. We don't need this. Just want to check something quick, and then you don't need this. And we not need this. just saying test. Don't need this. B. No input, right? And then we not need this. And then we're gonna say what we're gonna say. We say, for example, we initialize. For example, we say, for example, test is 1, right? Integer. And then we say integer test 2 is 2. So then we're gonna say we're gonna return. Yeah, okay. Then we're gonna return. What was the statement? Test equal 1 and test 2 equal 2. So that should work, right? And if I have my main here and say test B, that should work. So on what we're returning, you can check this out. C out test B. Ha! Interesting. Okay. And then 0, of course. Yeah, okay. Cool. Learned something today. That you can do it this way. I was not aware of that you can do something like this. This is pretty cool. Okay, back to the topic. Should make it a little bit bigger for you guys. So, of course, here we have here the forward declaration, and here we're declaring the stuff. Okay, that makes sense, and then we're just returning it if we have this state. So, okay, that makes sense. And then we have our card, and we creating our object named Corolla, Toyota Corolla, whatever. Then we have our car Camry or Toyota. How to pronounce it correctly? So, and then we have here this operator overloading, and then if this is equal this, we're gonna see out that one, right? And if this is not this, we're gonna see out this one, right? Okay, that makes sense. Interesting. And the input will be this. This is our input, what we have here, right? If you're creating the objects. Yeah, okay. This one is make, the other is the model. We're doing it with string view. Yeah, that makes absolutely sense. If it is only const, right? That's why we can use string view. So, So we're initializing it with this parameters, right? Oh, that's really cool to see the string view here live in action. That's pretty nice, right? Isn't it? Oh, is my camera frozen? Today it's working. Let me fix my camera. So, okay. So I'm back. So now it should work, right? Oh, now you can see on the left side my ski, right? My ski. Is it called ski or ski? Ski, right? In English, skiing. Yeah. Okay. Today a little bit. The start is a little bit chaotic, right? Lego TM, how are you doing, man? So first time here, or? So we have this one. This is everything is clear, right? It makes sense to use string view. Because we're just not changing the thingies here, so it makes absolutely sense to use Toyota Corolla and whatever. String view is like performance-wise way better. Then code here should be straightforward. Yeah, it is. What about operator? How to call this operator? Insertion and extraction, right? This was like. This is the insertion operator. The other thing is the extraction operator, right? I know. Wait, I have it here, right? So, insertion operator exactly, and the other one is the extraction operator, or the binary bitwise left shift or right shift. But in this case, it's like the extraction and insertion. This is insertion. Was just browsing the Twitch stream, my first time here. What are you planning to do with C++? For now, I have no plan for that. I'm just learning it. And if I finished my journey, then we'll see what I'm going to do. I did already something. I programmed like my own CSV file parser. It's not completely finished. It's working already. But I want just to add, for example, some UTF formats things, right? That you have... It's getting a little bit more than complicated because I need some time at least to fix the problem. But you can see it, right? 1 second. I think the latest code is here. Where's my stream? I'm going here. You can go there. That should be the current code. Why is the white? What the heck? Come on. Yeah. Yeah, here you can see it, right? Is it the project? Yeah, it is, right? Yeah, it is. These numbers here are not correct. By the way, so if you want to test it, you have to change this number. Why did he... What is the difference about const expert? I have to relearn this even again. Okay. Do you have to... Oh, nice. I don't know anything about C++. So why are you then here? Like, you want to learn it, or what kind of programming language do you want to learn? Just asking. So if you want to learn C++, maybe it's better, or like programming, just start with C, for example. I think it depends what you want to do, right? If you're not like interested in like to understand the fundamental things, then maybe it's better to go for the programming language Go. But if you want to get like a deep understanding why things look working like they work, is this make that sense in a way? I don't know. Okay, let's keep going. This is completely makes sense here. So if you have any question, let me know. QA automation. What is QA automation? QA. Engineering, or what is this? It's not quality assurance automated engineer, design automated tests to validate the functionality. Web mobile. Okay, interesting. But then you need some knowledge, right? Or am I wrong? Okay, let's keep going. We have this is clear. The code should be straightforward. Yeah. What about the insertion operator and the extraction operator? What would it mean for a car to be greater or less than another car? We typically then it's not extraction, right? That's the problem sometimes in C++, why it's really weird. And I think it can be really weird and bigger projects if people just overloading the operators and you don't know it and you have to work on the project. I think that can be really painful, and if you then even have like the template, then I think stuff is getting really fun. I work in JavaScript mostly. I mean, this is fine, right? So if you're like in web developing, it's completely fine. How many years of experience you have in JavaScript? So we have creator less than another car. Typically, don't think about cars this way, since the result of operator, insertion operator, extraction operator would be immediately intuitive. It may be better to leave these operators undefined. Yeah. Best practice: only define overload operators that make intuitive sense for your class. By the way, also like if you just now into the C++, this is like an advanced topic. This overloading thing. It's maybe not. I think it's better not to use it in your project if you're not really. Don't use any feature in C++ if you until you not really understand it completely. Until you understand it completely. This way around. However, there is one common exception to the above recommendation. What if we wanted to sort a list of cars? Oh, yeah, that makes sense. In such case, we might want to overload the comparison operator to return the members you most likely to want to sort on. For example, an overload operator for cars might sort based on make a model alphabetically. But you could just use something else like for the sorting thing, right? Could you? Some of the container classes in the standard library classes that hold sets of other classes requires an overloaded operator. That's not called insertion right now. It's called something greater, smaller. I don't know how to call it now. So they can keep the elements sorted. Here's a different example overloading all 6 logical or comparison operators. Okay, woo! Look at this beauty! Welcome to C++. Okay, we have class sans, then we have msans, then we have this constructor, right? Then we initialize the msans to sans. Okay, this is clear. Then what? Wait a second. Okay. Got it, okay. Then we have this friend thingy because we're not modifying the left side. Then this is the forward declaration, by the way. Then we have here, we're declaring all this operator, right? All this logic, and then we got just returning it with a 0 or 1, if it's true or not. And yeah, there must be a better way, right? There must be a better way. So then we have sense, and then we're creating the object dime, right? We initialize it with 10, and one time with 5. We can see that here, right? So we say msense is then 1 time 10, on 1 time 5. That's what we have here. And then we say if, for example, nickel is greater than dime, then a nickel is greater than a dime. Okay. So the compiler will find out if you have this overloaded. It will just choose the correct declaration for the overload, because it's the okay, we have this case here, so we were gonna go for this logic here, right? So it's defined. What would happen if we not have it? We would get an error. I can show that. I mean, we should get an error, right? Let's test it. Come on. Get up. Don't be a boomer. So we have this one. We're going here. Gonna test this. So if we just deleting this first statement, this here, this case, and we can call it case, right? This case. We're gonna delete this, and then we're going here. Also for the same case. What's this here? And then we should get an error. Whoa! Wait a second. Oh, C++. Wait, did I? Right, this is interesting. So we should get the first statement here, right? So this is okay. Why are we not getting any? A nickel is greater than a dime. Okay, we need this. We have to change the numbers like 10 and 5. So we should get output, right? A nickel is greater than a dime, so we have this, and now we're gonna delete this declaration or this case. So we're removing that one. And we have this here also with this friends thingy here. Yeah. So now we have it, right? Now you can see msense is private member of sense. Return and blah, blah, blah. Declare private here. msense is a private member of sense. Declared private. So we have now the friend function. So we have no access to msense, because if you're using the friend thingy, you can have access to this class member msense. So we not declared it, declare, how it called? Declared, right?
Declared.
Yeah, we not declared it here, so is it not defined it? It's more defined, right? You're defining something. Okay. Now it's declared, I think. So, good. That makes sense. We can keep moving. Any questions here? Probably not. So, this is also pretty straightforward. Yes, if you're understanding it, then it's straightforward. If not, then it's not straightforward. Then it's an overkill. In the example above, note how similar the implementation of each of the overloaded comparison operator are. Overloaded comparison operators tend to have a high degree of redundancy, and the more complex the implementation, the more redundancy there will be. Fortunately, many of the comparison operator can be implemented using the other comparison operators. So we have this node can be implemented as Oh. Okay, operator can be implemented as operator with the order of the parameters flipped. Oh. But can we talk then about the readability? Can be implemented as operator. Oh, okay. Okay, let's see. That means that we only need to implement logic for operator comparison and operator greater, smaller, and then the other 4 comparison operators can be defined in terms of those 2. Ah, yeah, because of this not right. Here's an update sense example illustration. Ah, that's smart. This is smart. But this is even looking better. Oh, my camera froze again. Nice. What is going on with my mobile phone today? What the heck? Maybe it's gonna work now. Let's see. Yep. So I am back again. So then we have the friend pool. We have all the thingies. Is it getting easier? That's the question, right? Oh. Are we even defined it here then? Okay, I can see it. So we have the friend operator here. We have all these thingies here. And what we're returning, then we have, this is the same, and we define it already here in the class. So equal is equal, and then we have this statement. Okay. And we're declaring this here. And it's a Siemens. Oh, this is interesting. But this would not work with forward declaration, correct? Oh, this is so interesting. I'm assuming that's why we're defining it inside the class, because probably it would not work in forward declaration. That's probably the reason for it. Why we did it this way. Let's check it, right? So let's take this case here. We have this here, for example, right? And we have it. I mean, this is fine. And we can declare. Oh, yeah, here it is here, right? We're just switching the statement, like. That makes absolutely sense. And that would not work with forward declaration, probably. I mean, if you don't know, try it out. But I assume it will not work with forward declaration. So if you say, for example, bool, and we have all this thingy here, right? Give me the thingy. We're gonna do a forward declaration here. We have this here. We're just gonna copy it. Quick and dirty. And we're doing it also for this here. Boom. Yeah. And then we're gonna remove the declaration part. Oh no, I removed too much. Forward declaration here, and let's see what's gonna happen. Wait, this is also working. Really? I mean, did we have the case even? So we're gonna say it's really working. Okay, forward declaration is then here not a problem. This is really interesting. Okay. I thought it's not gonna work. Ah, interesting. So sometimes I'm confused, right? Sometimes stuff is written C++ and sometimes it's not. So this is really interesting. Okay. Maybe we have this. We'll have some stuff here, like why it is like that. Let's keep reading. This way is we ever need to change something. If we ever need to change something, we only need to update operator equal and operator greater small instead of all 6 comparison operators. Spaceship operator. Oh no, I'm not gonna do it today. The spaceship operator, because a spaceship operator is a spaceship, right? C++ when introduced the spaceship operator, which allows us to reduce the number of some comparison function we need to write down to 2 at most, and sometimes just 1. Author's note: we intended to add a new lesson on this topic soon. Until then, consider something to pique your interest. But you will have to go off-site to discover more. Okay. Add the 6 comparison operator to the fraction class so that the following program compiles. Input reduce in the constructor. Hey, what is this statement? Let's do it quick. So go. It's not compiling. I have to add all of these here then. Really? Okay. So we have void reduce. He started already, whereas this here, and then we have to do it also for the other ones, right? Yeah. So we have to add then friend equal. How was it? It's friend operator equal, and then we need the input, right? And what is it? It's a string view in this case, right? We'll have to check quick. String view, friend bool. Bool I have to add also. Yeah. Of course. This is not enough. Bool operator equal, and then we need string view for the comparing. So it will be. Oh no, it's doing. Okay. Yeah, no, what I'm doing, it's completely wrong actually. We have to do it with constant, we have to do it like then there. Should read the code more carefully because we have the numerator, the denominator. So that means we have this here. And then this here, right? Oh no, what I'm doing, we not need string view. Make no sense at all. So we just have it. It's just integers. So what you're going to do is fraction. const and then the because it's only read only, because we're not going to change it. Makes sense. Then we have, for example, what is the name of it? Numerator, right? Denumerator. So we can call it the same name. And then we can say const fraction. And we can call it also. I could call it even like C1 and C2. It makes no sense. So it's the same. It's and we have to do check this if we have so we have numerator is integer equals 0. Denominator is equal 1. We put reduce in the constructor to ensure any new fraction will any fraction that are overwritten will need to be reduced. Huh? What is even the program doing? So we have fraction f1, 3 do. 3. What are we doing here even? Ah. Okay. What is my problem? Then we have reduced here. Then we have G. What is this here doing? Wait, what stands for greatest common? Ah, okay. There is a language barrier here. The greatest common divisor. Okay, 12, 12. Fraction find a 36, and this is like 12, right? Mm-hmm. Yeah. Okay. So the numerator will be the 3 and then the 2. So it will be 6. Right? That will be the 40. That's the 6. Void reduce. What is this doing? So if just stood. What is this statement doing? Man. I don't know this operator. Division assignment. The division assignment operator performs division on two operands and assign the result to the left operand. What? Ah, okay. Got it. I got it. So we're gonna add this one. So what is this function even doing? I don't know. I have to test the function before. Never used the GCD thingy here, right? The std GSD. So we're getting the... So I mean, I should try it out before. Did I know how it's actually working? So... can delete this here. So, and then we can say it's the std, right? Numeric, we have the numeric thingy. And then we just can use it. Std GSD, okay. Okay. And then opening it up. And it needs a number. What was the example? 2 and 3, right? Exactly, and then we can say, okay, print us the stuff out. And we want to have it here, and we should get 6. Are we getting only 1? Wait. Okay. So computer's greatest common divisor. How it called? Divisor? Let's check.
Divisor.
Divisor. Okay, we have a divisor. Okay, the biggest, right? Want to have the biggest, the greatest, yeah. Common divisor of the integer m and n. If either m or n is not an integer type, or if the either is possible CV qualified bool, the program is ill-formed. If either m or n is not representable as a value of type, the behavior is undefined. Okay, so we can have undefined behavior. If both m and n are zeros, return 0. Otherwise, we create as common divisor of m and n. Okay. So here we have static assets, and here we say 6 and 10. So we could have 2. But you could have every time 1. Why are we getting 1? Now I'm confused. Does someone have an answer? 3. Why it's 1? It's 3 and 2. Is this the reason? Then it's 3. No, it's also 1. Größte gemeinsame Teiler. Willst du mich jetzt veräppeln oder was? Ja, ist 1. Macht ja Sinn. Ja, it's 1. Ja, beide teilbar. Ist nur durch 1 teilbar. Die größte. Ja, okay, got it. It was kind of a language barrier here, to be honest. So 1 makes sense. So if you have 6 and 8, it will be 2, right? Yeah. Okay. Next step. Now I know how this is working. Okay. So we have it for the numerator and we have it for the denominator. What is a denominator? Numerator? What does denominator means? I mean, I'm also learning English, it seems. Ach, auch Nenner, okay. Okay. So we have 2 inputs. Okay, what do we have? So reduce. Why we want to have reduce? So we have this, then we have GCD. So if we have a number, what is even this? Are we reducing it? Okay, got it. And then we say M numerator, and okay. But with 0 it would not work. So we're reducing it. I get it. So we have 3 and 2. It's going here. That will be 1. Then we have here 1. And then we have like GCD. It's 1. So it's nothing will change, right? In this case, nothing will change. For the other case, for 5 and 8, something will change. Will it? Five and 8 is... It's the same 1. Right? Same thingy here. So we're gonna reduce nothing here. This makes no sense. Why, if you have this fraction thing? What are we returning? So we have this. Okay, void reduce. to ensure that any new fraction we make get reduced. But so this is nothing else. Like if you're gonna say numerator, and it will be 1 then here. So numerator divided 1. Make no. Huh? What is this weird example here? It's then still the same. Numerator, denominator, okay. We have this. I mean, you can do return type if you want to check. Or we're just gonna print it out. I mean, yeah. We could just say, please print me out one time the m numerator. Thank you. Maybe I'm missing something, I don't know. What am I missing? Because of the... Yeah, it's not gonna change, of course not. Yeah, okay. Don't need this here. Yes, 3 and 2. Nothing. That's such a weird example, right? So this is not really important to know, even like for this task. Oh man. Okay, so nothing we're gonna change here. It's just gonna change if you do something like 4, for example, 4 and 8, right? Because then it will be 1 and 2 in this example. Yeah, makes sense. What? And my camera freeze again. Nice. Why? I don't know. Gonna check. Today, guys, I don't know. Sometimes you have days. Camera is crashing. Crashing on the. Have like problem with the task. It's not Monday. It's not Monday. Okay, yeah, okay. This is a weird example, but I'm gonna accept it. Um. So this is a quiz. Yeah, okay. So we're gonna do this. Bam. Gonna redo it. So nothing will change, right? So they are not working, so we have to define it. I've been a while now. Yeah, I had like a break for 4 weeks or something, 3 weeks for C++. It's going good. Slow and steady. Today's topic is comparison overloading, comparison overload operator. What is the first one? Equal. What is the class name? Fraction. Are we gonna define it outside the class, right? So we have this 2 as an input. I mean, we could already define it here if you want to. For this, Was it M numerator? Yeah, it was, right. Equals M denominator. This is wrong. M numerator. Wait, if you have that one, we're gonna say 0 and 1. What? Emotes are disabled. Yeah, because I'm streaming also on another platform. 0 and 1. Wait, M numerator. So we have M numerator. It's 0, initials with 0. And then we have... Wait, this is wrong here. That makes no sense. When we have an input 3 and 2, yeah, that's bullshit. Then we have the fraction numerator. And we have it here, 3 and 2. Fraction f1. We're creating the object with 3 and 2. And we have our friend bool operator is equal. What am I missing? Am I a blind man here? So friend bool, I should have access. Use undeclared identifier M numerator. Why it's undeclared, right? So if I'm declaring it outside there, it should be that one, right? If I'm returning it C1, it's because of the object, right? My mistake, boys. My mistake. So we have to do, for example, C1 numerator and C2 numerator. Right. Yep. That should work then. So we have the bool operator, blah, 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 if it's equal, blah, 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 right? So for this case, and then we should have the same. For the other statement. I have one question. If I'm doing this method, what I'm winning there then so much? I mean, I'm still getting 1, 2, 3, 4, 5, 6. And here 1, 2, 3, 4, 5, 6. What I'm winning here? I mean, minimizing comparative redundancy. But yeah, probably this will be faster, right? That's the only reason. It must be like that. Yeah, we can keep going like this, right? Why we have C2? We need like also like this here. It's equal. And now we have to do it for the other things also. We have to do, for example, bool operator, the same thing. And then we have to say for the now we have to write it here then. And that should work, right? Yeah. No, we have to have like operator thingy before, otherwise it's not gonna work. Okay. Yeah, that makes sense. That's actually not working, right? If you say C1 equals C2. Because now I have not a matching operator here. That's probably a problem because of this here. Because we have to declare it here. And then this is working, you know. Yeah, okay, got it. Then it's how it's actually how I expected, right? Because of this. I think I need this. Oh wait, we have this here still. A not matching function for operator. I mean, we have an operator like this. Now it should work. I need this now in Visual Studio. I don't know. The bigger screen. Let's do it quick. It's actually only this here. It's the same statement. And now it's working, right? Okay. And I not could do it here? That makes no sense. I mean, we're gonna try it out for sure. Yeah, and then it's not gonna work right. Too many parameters for this operator function. Bool bool. I mean, this is correct now. But it seems not working, so we can't do this forward declaration, and it makes sense. Too many parameters for this operation function. Why are we getting this? So overload operator must be in binary operator, has 3 parameters. I'm just asking myself if we can do it with forward declaration, but it seems it is not working. If we would do this here, it's not working, right? I mean, this should at least work. What I'm missing, Frin all over equals. So what it's saying, fraction C1, fraction C2. Even I'm deleting both of them. Still getting here the arrow. So this is now working. No, wait, I need this here. Okay. But this... So this here is working without any problems. So what we're going to do, we're going to just copy... Yeah, we're not going to copy this completely. We're going to say friend, and then we say operator equal... And then we're just going to say, what was it, C1? The M nominator, M... numerator, C1M numerator, and C2. What I'm doing? What is the name of the class? Fraction reference, and then C1 fraction reference C2. And we're not going to define it, right? Here, oh, we're getting already this error. Wait. Bool. I missed the type. Oh my goodness. So now it should work. That was the reason. Let's say bool operator. And then it's actually the same. Let's check if this is working or not. C1 fraction reference C2, and then we're gonna define this return, and this is C1 M numerator equal C2 denominator, right? My brain is not working today. It's fantastic. So, okay, we have this one. Now we're doing the same for the next one. We're just going to modify it a little bit. Gonna say this. Then we not need this because we're saying C1 is equal C2. Then we need the operator. The equal operator. And then we're gonna say this is in the equal operator. And then we're gonna close it. That's it. Was ist heute mein Problem, ey? Zweifache Klammer und dann kommt das. Ah, my mistake. My brain is not working at all today. Okay, forward declaration is also working or what? Finished like this, right? So you can do this forward declaration thing. Okay, good to know. And then we have to do this. And it worked. Perfect. Wow, this is interesting. But still I need this here, right? For the... Wait a second. I not need that? If I'm doing the forward declaration, I not have to do the friend thingy? I have to, right? Yeah, of course I have to. Yeah. Okay, we have this, bool operator, that one. So then now we have this. Now we have to do the next one. And for which kind of case it is for this one. I mean, we can copy it for every case here. Then this here. Oh, what I did, that was wrong. Two more. Okay. Huh? What is now here? What is your problem? Undefined reference to operator fraction. Huh? I have two questions for you. Do you mean with for declaration, and what does friend do? For declaration is it not like this here? So I'm declaring it before, right? And what a friend does is that I have access here to the numerator, right? If I'm declaring it later. Otherwise, if I'm not going to use, for example, friends, I'm not able to declare. Where is it? I would not have access to this object. Like this. Would not work. I mean, I can just show it to you if I'm removing the friends thing. You see? No access to M numerator. And why I'm using friends? Because I'm not changing the left side of the operator. For this scenario, I should also add a const, right, for readability. So what I can do, I can say const here, const there. Then it's a little bit more clear. And huh? Yeah. I think the friend thingy with the function is indeed a forward declaration, but the property of the forward declaration is not why you write it there. And friend allows you to access private members, so oh yeah, this is yeah, we not need it, right? For this case, we not need the friend thingy, right? But they did it in the example. You see? You mean you not need it here, right? Yeah, they could left it out. It makes sense because we not need access. Yeah, I know this. But thanks a lot for calling it out. I was just asking myself, you know, they not did it with like the forward declaration thing. If it's gonna work with forward declaration, it's gonna work with forward declaration or not. That was my question. Why I did just did it in another way. I mean, but you're completely right. You don't need a friend thing here for the thing. It's so we have the friend bool const fraction c blah 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 blah, and then you can do this. Huh? What is the problem? I have the friend thing. And then we can just return. Huh. I mean, we not declared it yet. No, that's why we're not able to use it. So we have to use the C1 numeric. A numerator. And then we're gonna say this. Right. Oh, linker common error. Here we have a big error here. So, but this should be correct. So, but this overloading topic is a really big topic, right? Isn't it? It's crazy. So we have this one, and then we can do the other thingy, like this here. Oops. Then you can have it like this. Define it, friend off. And then you can say, for example, return. And then we're just gonna change it, right? Just have actually the same thing here. Wait, this is the same case, right? Than before. Yeah, we can use the other operator again then. And then we can say just the operator. And then we're opening it up and we're just changing C2, C1. And that's it, right? That's what we're gonna do here. Yep. And for this we not need friends actually. And then we can say next topic. We did it for this and this. And now we can even do it for both of them. How I'm gonna do it here. Both of them are already declared, right? So it's not bigger, right? It's more like it's not bigger than. So I have something like this, then operator. And it's this here then. C1 and C2. No, okay, fucked up. Yeah, that should be correct. And then the last thing what I would have is the other way around, right? Now I have two options. I could use even this here, right? And just change it up. I mean, there are two ways to do it. I mean, you could do something like this. I'm not doing this operator, and then just saying, okay, we have this one, and then we can just change it up. Can we do this even? If you have equal call? Yeah. It's the opposite then. This is not gonna work. We're gonna redefine it then. No, we have just to change it in the other direction. Yeah. So 3 is bigger. Yeah. Yeah, it seems like it's correct. Let's see, what was the solution here? So show solution. I had to do it in the same way, okay. Oh. Oh yeah, I fucked up a little bit. Actually, not even a little bit, I fucked up big time. So we have to do the same thing here then. But here if you have the equal thing, yeah, the numerator 1 and the second has to be the same. So yeah, huge logic failure here. So, because this makes no sense, right? So what we need here is following numerator C1, gonna save it, do it here. And then need also this one. And we're gonna say denominator. Because we want to compare, right? And if you want to be safe, doing this. Just in case, because of hierarchy. Okay. So, that should be correct. Oh, what are we doing here? So we say f1 m numerator multiplied with f2 m denominator. So, okay. So we have the fraction f1, f2. Why we have to multiply both of them? So now I don't know the hierarchy here. Numerator multiplied. Why? What? I mean, it makes sense that I have to do something different here, right? Mit den Zähler und Nenner und... This is not correct. Why we have here multiplication? Oh, it's F2. Ah, okay. Okay, it makes sense. Yeah, okay. Yeah. Yeah, okay. I thought for a second this is F1. Yeah, okay, that makes complete sense. Sorry, guys. That's funny. So C1 numerator multiplies with F2. Then we have this one. C2, sorry. Denominator. C1 numerator. That should be correct, right? Yep. Be right back. Give me a second. Should I do? Okay. Mm-hmm. Should be correct now. Mm-hmm. 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 Yep. So add an overload operator and operator to the car class at the top of the lesson, so that the following program compiles. Okay, this is now working. Now we can open a new thingy here. We have here one. So oh, we have this vector. Oh, wait, this is not even working. Ah, because we have to create the class and stuff like this. Uh-huh. I don't want to type it with the via hand, so we're gonna just take this example so it's going faster for me here. So then we have no, don't want to wait. Not this one. Where's the car? Here. So okay, now we have the cars. Std string make model. That's already all or what? Wait, no, it can't be. Yeah, in this case we're gonna use std string view, make and model, Toyota, Corolla. Is it even make? Can we maybe we can even call it. No, it's fine. Okay, this is working. Then we have the equal and then this one. But we not have the operator here for printing it out. So we're missing that one. Requires an overload operator. I mean, that's doable. Then we can just define it here. Bool operator const car C1 const car C2. Then we're gonna define it and return C1 make Is this even working like this? From the sorting? Oh, this is interesting, no? I have to think quick about that. I don't know how this is working, you know, the begin and end. So what we sorting here? So we've stood standard library sort. Then cars begin here, cars end here. So we're gonna sort this list or what? I have to check it how this is actually working. So let's check. Oh, nice. A sort of elements in range first, last. Okay, so we have one first and then last in non-descending order. The order of the equals element is not guaranteed to be preserved. A sequence is sorted with respect to a comparator comp if for any iterator it pointing to the sequence and any non-negative integer. No clue. Elements are compared to use the operator. Okay. So we're checking the elements. Okay, elements are compared using the given binary comparison function comp. Same as 1, 3, but execute. Okay, I need the example. So first, last, the range of the elements to sort. Okay. N comparison. Okay. So we have this one. We have an array from type integer, size of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're gonna use string view, const rem. Okay. So then we say sort as begin and as end. Okay, sorted with the default operator. The type will be auto. What the heck is this here? What is the default operator? Oh, that will be not that easy, I guess. Sorted with the custom less. So with the custom function objects. Oh, okay, here we have it. Sorted with a lambda expression. I don't know, guys. Okay, step by step. What I know. Requires an overloaded operator. So we want to sort the list, right? So we know that the ASCII table, check the ASCII table. Oh, dude. Okay, I have a solution, but it's not really beautiful. Sometimes I hate programming though. For real. Because I really not like my solution. That's like a brain dead solution. So we know, okay, we can say 65. So we need like a comparison 65. So if 65 is smaller. Oh, dude, this is like, I don't know. There must be easier solution. I mean, I have a solution how to do it, but I don't want to look it up. But I think I have to. So if this vector I don't know how this functions work in this problem. What is the cars begin, cars end? I don't even know how this sort thing is working, and that's my problem. If I know how it's working, I know how to this operator. But I need a example. So we have, for example, this here. Okay, and we have this. Okay, this is okay. Then we have the vector, my ints plus 8. Why a plus 8? My ints plus 8. Other size, okay. Using the full comparison operator. Ich weiß, I don't know how it's. I have to look it up. It takes just too much time. I'm gonna check it up. If you need a refresher or sort we talk about in lesson. Okay. So let's see what was the solution. Okay, this is fine. That makes sense. Okay, now the other thing. Friend bool operator const. Okay, this is fine. C1 make is not C. Hey, what is this sorting? This is weird. It won't just sort Toyota and Honda. Yeah, okay, this is not that hard. I mean, this is doable then. What chapter is it? 21.7. Sometimes it's better to read the text. I was like, it was like Toyota and the type of the car, right? Toyota Corolla. So it's just Toyota, Honda, right? Sometimes it's better to read the output, right? No, Honda Accord. Honda, no. Huh? Still not getting it. So we're comparing C1 M make, C2 M make. Okay, so we're comparing this with that. With that. No, with that. Now C1 is this and C2. Okay, we have object one make, right? And then it's okay if this is the case. If the car is not the same, then compare the make. Topic is actually overloading comparison operators. And my camera is frozen again today. I mean, today is a day, guys. I really could rage today. It's crazy. This is a hard C++ day today. And the topic is not really that complicated, you know? Okay, so Toyota, Corolla, Honda. And what we're doing, we say, okay, we have object 1 here, car1, car C2. So this is one, I want this here and that. Right? That's our input. So we're gonna say if So we have a vector. In this vector we have the data. Why I'm so confused? Because of the stud vector car. Because I never did this here, right? This is the reason. So we're creating the object car. We're creating the object cars, correct? Is this correct? But what is then C1 and what is C2? It's killing me. I mean, this is C1 and this is C2, right? Go up, check it out. Yeah, make and the model. Both are cars, right? Yeah, but I'm a little bit confused. Because if you're saying C1 is C2, but what is then C2? Is it then the Honda, Toyota, or Honda? Because, I have more data than... What? Wait, no, both of them are C1. Yeah, you mean Toyota and Corolla is C1, correct? One time make and one time model, correct? And C2 is then this here or what? Is one car. It can be either C1 or depend on what's the sort called. Yeah, and that's actually welcome to C++, and that's the problem, right? I don't know what it's gonna be called, right? That's why I'm so confused here. So everything could get called here, right? So you have to understand how stud sort is defined, how stud sort is actually working. So it doesn't matter what it's called. Yeah, but from the logic, I mean, if you see, you have already later made this knowledge, about. If you're seeing that for the first time, it's a little bit confusing. I was not even aware of that you can do something like this, but it makes sense, right? It makes sense. It does. You don't need to know. Yeah, you don't need to know it, but if you're aware of like the pitfalls in C++, you could just say, okay, I'm just doing it casually, but if you want to really understand it and you have to question yourself if you really understand what's going on in the background, then this is not enough. How you should know it's just picking something. Yeah, okay. So it can be everything. Yeah, I get it now. Where is this? This is easy. Then we have this here, the car, C1, C2. It can be one of these. And then we say C1 make is equal to C2 make. If the car is not the same, then return place C1 make is smaller than C2 make. What? Why I hate this topic so much at the moment. I could rage. Oh, why is this even sorting then? Ah, because it's defined this way, right? So C++ is defined this way. If I have, for example, let me try it. Where is it? I need an example. Okay, I got it. I think I got it. So if you have this here, let's do it quick. Opening it up for me. So we not need this here. So if I have, for example, let's create a string. Test equal. Okay, I have something. Apple. And then we make another string. Test2. And we call it just B. And if I'm saying what, yeah, and then if I'm saying what is bigger, really? How does C++ know that Apple is? No, it has to be the other way around, right? It has to be smaller, right? A smaller B. How is this comparison thing defined? I mean, we have a string. How string? Oh, it's crashed again. My mobile phone. Mann, ey. Funktioniert heute gar nichts, ey. Ich bin so angepisst gerade. So letter made. It's how is string composing working in C++? I'm gonna check. How is string composing? Working in C++. Yeah, so you also don't know how C++ is actually doing it, right? I mean, there was something, sorting arrays using selection sort. Was it that one? Oh, always the string stuff in C++, it's weird. Oh, that's the selection sort? Oh, that's good. I should redo it. So if we... So if I'm comparing it, right, C1 with C2, how is this comparing process? How is this operator comparing the objects? And the objects, you know, what we're comparing is are actually string, right? And we have here a string view make and model the same. So it is a string. C++. So and strings. Well, I could rage. I really could rage right now. So frustrating. Alter. Now I'm trying to figure it out at the moment what we're doing comparison overloading in C++. I don't know which kind in which kind of language you're all in. But my question at the moment is, how is this comparing of the strings working? What is actually getting compared? Is it the size? What is it? If it would be the size, it's just a shitty solution. Wait a second. Maybe it's not the full thingy. Maybe it's just this here. Could it be? No, it could be. It could be, right? Cast begin. What does cast begin means then? Is it the... I mean, if it's using the ASCII table, and if I have, for example, cast begin, and it would just compare this and this, for example, right? Is T and H have the same number, yes or no? Right? What is smaller, what is bigger? Then sort it. If it's equal... Wait, I'm gonna open this here. Welcome to C++. A world of punishment. So we have here this bool operator. Okay, constant basic string, charge rates. Wow, this says me now a lot, right? Wow. Alloc, okay. Now I can jump there. Yeah, I know, it's hard to read. Templates. Hola. So can you give me maybe the answer letter, mate? OP overloading is a mistake. What do you mean? Ah, here, compare two basic string objects. Ah! Okay, let's check. What is a trade again? Ah, right hand side value, left hand side value. So we're comparing every... Boris is my head. I'm so angry at the moment. Could hit the table. So it's sorting after the alphabetic characters, right? So, oh, perfect. Here we have an example. Std string s example. Then we have s. Okay, I can live with begin. Is equal e. Okay. Excuse. Okay, it knows when it's starting, it knows when it's gonna end. Okay, got it. So this is also working like this. Uh-huh. We have C begins. Okay. Ey, das ist ja echt eine Tortur, ey, ohne Scheiß. Okay, what is getting compared? Like every letter here? So of letter 1 with letter 2? Or how is this working? So first it's the strings getting compared, right? And the string is like also kind of function. Ey, das ist so ein Scheiß, Alter. Das regt mich so richtig auf. Und die Kamera ist schon wieder abgestürzt, Mann. Sorry. What the fuck? Why not device found here? What's going on? Hello, PC. Hey, Mann. Ey, ohne Scheiß, Mann. Ich geb's auf. Ich geb's ohne Scheiß auf. Welcome back. So can someone help me with this problem here? How is the string comparison working? I'm just gonna ask ChatGPT. If chat is not helping me here, it's just. What's this here? Was auf Deutsch? Mm. Ah! It is how I said it. They're using the ASCII table. Oh man. So every thingy here will... It's just using this object, right? So... Okay. So if we have here string and we have here string, right? So we have one of these this one will be compared with that one, right? For example, Toyota and Honda. And then it's comparing the first, like the T and the H, and what is bigger, alphabetic wise. Okay, and then we're getting true or false, right? Return, yeah, bool, yes or no. Okay, it's bigger or not. Else return, otherwise compare the models. So if they are equal, so if they are same, we're gonna do it with the model. That's how it's working. So first we're comparing all of this, and then we need the else return thingy, like Honda, because it's the same name. And we want to still sort this one, right? And we need a chord, compare the chord and this civic, or how it's called, I don't know. Yeah, that's how it's done. Correct. So yeah, of course we need the operator equal, because cars can be equal, so we have to do this operator overloading also for equal. And then if the car is not equal, we need it also for that one. And okay. What do you mean the year of versions? I don't think that's how he defined for cars. What do you mean? The year of versions? I mean, you have only here these cars on the models. And we have this overloading here. The operator here defined. And we defined it here, correct. So we're getting back in this comparison. Okay, and this, why are we doing this? Because for this stud sort thing, we need the operator for cars. Otherwise, the operator is greater than or smaller than is not defined, and we need it, right? Requires an overload car operator. And that's the reason why we have to do it. Woo! And here we're gonna print it out. That's what we're doing here for const auto cars. We're just gonna print it out. It's the new 4 thingy here. And for this we require the overloading operator. Yeah, this here for the car, because it's also not defined. Wow. What a topic though. Holy moly. Yes. I'm gonna redo this. But now I know how it's working, so crazy. I can understand why people really like C and don't want to shift over to C++, for example. I really get it. It makes sense, right? Es ist... Oh, meine Güte. Overloading the comparison operator. I'm so gladful if I finish this overloading topic. This is crazy. I mean, the problem about this overloading thing is, right? I mean, it's not a problem, but you could... The thing is, sometimes you're like in trouble because you don't know how actually, for example, the stood sort is working, right? And if you're doing this overload thing, you have to define the stuff what it's needed for. For example, for the cast, then here the overloaded operator. Oh. It's not the overloading aspect. Yeah, okay, to be fair, it was not the overloading aspect. It was more like the how it's again strings, right? It's always strings, right? Strings are kind of special. Yeah, you could do your own sort. It's true. Yeah, you not have to do it this way. But it's cool if you that you... I think it's good for practice to know it, right? It's also back then where we talked about the topic, what is the difference about arrays, strings, and vectors, right? Remember? Was also really great. I'm a little bit angry, to be honest. So, but what is going to happen if you're using stood sort without defining the operators? It's not going to work then. Like, because you use just, in this case, you used like cars, right? It's not going to work then. I mean, you have to define the operator in this case. I don't know what lambdas is. Still don't know. Or function pointer. Okay, maybe this is the other topic then. Probably it is. Boy. Actually, do you know what I like? There is so much depth in C++. But sometimes it is also overwhelming. Because if you're not understanding everything, it's really hard to understand anything. If that makes sense. Crazy. But to be honest, sort. I mean, I had like just here like a problem because I don't know how C++ is just comparing strings. But now I know how it's working, right? So then it's fine. Then it's completely fine. So not a big thing anymore then. So I can read it because I know what's going on. I mean, probably you have to fail in a programming language to get good, right? Yeah, I have to do still lambda. I still have to do it. Oh, my girlfriend arrived. 1 second. So gut. Ich komm gleich. Ja, ja. Scheiße. That's not a real definition. B helps understand the term. What do you mean? Think of Lambda as an annoying mouse function without an explicit name. Defined implies radius. Yeah, lambdas I have to do. So tomorrow we're gonna do. How long I'm in? 3 hours. It felt like 4. I'm gonna redo this topic by my own. Just do some practicing. This comparison overloading thing, and tomorrow we're gonna do this overloading the increment. How to call this? Increment.
Increment.
Increment, right? The increment operator. Are you using this operator overloading thing a lot? Or is it like advanced stuff? Overloading increment and decrement operators. Oh, you can even overload them? Oh no! For real? Oh, nine. Really? Yeah, you can overload everything, right? You can just find your own language. Oh, no. What is this topic, man? Oh, no. Okay, it's not that big. It's doable. Ay. Okay, this is a topic for tomorrow. Okay, guys. See you tomorrow, I would say. Thanks a lot for watching my stream. And I wish you... What is it? Still a good day. Thanks for the support. I'm out.